Hello SSG followers and YouTubers. So this is my 12 charging procedure. Let me quick show you my equipment. On this side you are looking at the charging battery. First of all, milliampere meter and voltage meter. And here you can see the voltage. Pretty nice picture. I did not start system yet. 11.96 volt after last discharge procedure of the charging battery. And you can here see the state. Fully charged primary battery 12.53. The primary battery was charged by the conventional means with a conventional charging device. So if you are watching this video for the first time, this is not an over Unity device, but this is an actual device which is used by the simplified Schoolgirl Bedini systems. I mean, this is a standard Bedini SG circuit with one transistor. So now I start the system. Maybe we hear some noise. Okay, immediately you hear the self-oscillation noise. My solution is, you see 70 milliamps. This is wrong milliamps usage. I disconnect one of the connections from the SSG circuit, then reconnect once again like this. Okay, so you don't hear any self-oscillation noise, and now I actually can run the system. Okay, let's do this. I move the wheel like this, and charging procedure started. Immediately you see the voltage increase to 12 volts. This is actually very good charging rate. But I must say, what actually changed from my previous charging procedures? At least 5 charging procedures. After charging the charging battery, this battery, I use a conventional discharging device. Imagine like solar panel charging device, where you can put load and you can connect the battery. So to discharge this battery, I use this device. I connect the load and connect the battery, of course without any other power sources. So this is it happens separately from the SSG circuit, and I clearly see difference between manual discharge to 11 volts and the automatic discharge procedure. So automatic procedure, when I want to discharge the battery, is much better because the battery shape, I mean the resting voltage each time increasing, and you can see here 12.02. So it's a pretty good voltage rate which I get when I charge the battery with the Bedini SSG radiant type impulses. So as I stated earlier, I do not charge the battery with the current, because you see here the current is like 14, like too little to charge this battery, right? But what I actually use, I use the impulses, the type of the energy which you can only observe with oscilloscope, and even with oscilloscope you are actually can see only one slowest part of this type of the energy. And this is actually funny because I put the light on this like this. You see here 12.43 volts on the primary battery, and it's like 31 milliamps on the primary side. This is actually what I currently spend to run the system. But anyway, it's enough. This actually very interesting observation, because you see here that I use actually less than 29 milliamps to run the system, and I got this current, this voltage level, and this voltage level is increasing and holding. So that last time I did actually got a 12.74 volts after charging procedure by the BDINI SSD circuit. So what I actually want to say, that is really possible to do very good charging of the second battery. This is my charging battery, which I always charge and discharge. And I discharge this battery by conventional means. I actually put 250 milliamps load. I think this is for the first time which I say how much load I put to the battery. So I do the C20 discharging rate of the battery. But to control the under discharging level, so I mean to discharge this battery without damaging it, I use this solar charging device. This solar charging device, which I said earlier, has the functionality to control the voltage and to keep the battery at the safest discharging voltage level. So for me it's very good, and you clearly see this voltage increasing, so actually battery in very good shape. And this is only my 12th charging procedure. You saw my previous video, so it's not actually very fast charging way. Why many people want to charge battery at the highest amount of the spinning of the wheel, and I personally don't see any sense in doing that. This is not conventional system where you run motor generator and produce current. This is actually something different, because what is the reason why I need this wheel? I need this wheel to switch my magnetic field in the coil and to turn on the circuit with my transistor. So the wheel actually is a minor thing in the BDINI circuit. The most important thing is the battery, the quality of the battery which you have, and the type and the amount of the impulses which you get on your system. Because to run at maximum, to run the wheel at maximum, it should be probably with BDINI. If you have such type of system and run the wheel too fast, you're probably losing a lot of energy, because idea of this whole thing is to use this wheel only to do the switching work, only to use the wheel for producing these impulses. So each time when the wheel passes the coil core, with a magnet, I gather some type of energy, and you can see this type of energy at my previous videos, where I show my oscilloscope picture, and you can see there at least 14 or 13 impulses which I can get with my type of the system, with my following setup of the system. But what I'm trying to tell you, my personal beliefs in that regard, if I had a lot more windings at the coil and a lot more suitable transistors, I probably even spent less energy or I will use the same amount of energy which I currently use. This is like 27 milliamps at 1241 volts. But the idea is actually, if you have a lot of this type of impulses, you actually probably able to charge even more batteries. But with the one type of transistor, I'm not sure. This take anything a lot of time to do the proper charging procedure. But if you're able to build the system with a lot of transistors. I know it can be some sort of headache, but in any case it will be pay off, because if you produce more impulses, you can charge even better your battery, and probably faster the battery. I mean, the charging rate of the battery will be even faster than you actually expect. And currently, what I currently observe, I observe the situation where my battery was previously discharged to 11.74. Then the battery voltage level after some hours get increased to 11.94, and currently when I'm charging, the battery voltage increasing, not rapid but steady. And this is picture like this. So charging procedure happens anyway. The battery is charged, and where I'm going to with my type of system, I actually want to do another 7 and 8 charging procedures and discharging procedures of the battery. But at the end, I will get very good quality charge on the charging battery, and then I will try to use this charging battery, to actually charge another battery. So in this case, if I succeed, I probably use this primary battery to charge with the Bedini circuit again the charging battery. And when it happens, it means I can do the same type of charging, but I will not pay any costs or any additional cost to charge my primary battery, because each time when I hook up the inverter to my charged battery, this inverter will be connected with a conventional type of charging device, but I will spend some energy, but I will gain some energy in another battery. And I will do this and probably again 20 times if I'm lucky. And I will do my conclusion on the SSG and where I'm going currently further with this research. Yeah. So random faults, once again, you are looking for the radiant type impulses. And this radiant type of impulses you probably can get with a high resistance like 2k ohm, but in any case this is each time special case, because it depends on your coil core, on the height of your coil, it depends on the amount of winding, it depends of amount of bright of your winding which you use in the system. So my best advice, do the first project like this and go further with this. Some people want to actually able to control the movement of the wheel to do this efficiently. I'm not concerning that my wheel should be spin like hell. What I'm only concerned currently, I'm concerned only about charging battery, and the movement of the wheel is for me secondary. But I can only imagine how it will be great if I build a fan additionally on this wheel, which actually will produce some wind force. So if you are able to send me like, I don't know, 14-inch fan from aluminium, or just not magnetic material. I don't know if I even can use this in my build. Now, what I'm actually hoping from you people who are watching this, if you have some wind generators, DC wind generators, with a fan on this type of the generator, and the fan height like 14-inch in diameter maximum. I don't need large wind. I don't have any place to do this. But actually what I'm always thinking when I see movement of the wheel, how I produce enough wind energy to power to get the wind turbine running. So when I like just imagine when I say this is an energy force system, the system produces energy. I need to utilize this energy. One of the part of the energy I utilize in charging the battery, but I want to utilize the mechanical energy. It's not 100% power, and the movement of the wheel I think is probably not enough to spin some wind turbine, but it should be tested carefully and equally measured. And I don't know, it's just random thing about research. And some people say you can even succeed best charging results with a capacitor. I'm currently, I can only say, if you're using a lot of transistors in your type of system, maybe it's a good idea. But if you use only one transistor, and you should always remember, if you charge the capacitor to the 1200 volts, for example, and then you discharge this 200 volts in the battery, I don't know how is actually good for the battery. So think about this. If you want to build system with a capacitor, you should then control the capacitor discharge rate. That if you are successful with the control of capacitor discharging rate, then you not kill your battery. This is actually one real reason why I don't wish to use any additional capacitor in this type of the system. And yeah, it's charging, and when I disconnect my circuit, then I see this lightening up, and this is actually like 240 volts going through. Yeah, so it's actually charging for me pretty well. Takes time, but it takes enough time to get to the needed voltage level of my charging battery. So I thank you all, and good wishing you time. Bye bye.